Howdy, I'm putting up this to alleviate some of the homework woes. So let's just go ahead and do that. So square root 180 over square root 3. Well, you can reduce this. Both the numbers are inside the square root, so that's square root 60. And then are there any perfect squares that go into 60? There were perfect squares that went into 180 as well, but I might as well reduce it first to make the problem a little easier for me. And yeah, 4 goes into it 15 times, so that's 2. Square root 15 is my final answer. 63. I have square root x squared over square root y cubed. Okay, so the first thing I'm going to do is I'm going to say, well, how many times does 2 go into 2? That goes evenly. 2 goes into 2 one time. How many times does 2 go into 3? One time, with 1 left over. Okay, so nothing reduced, so I went ahead and simplified the radicals individually. Now, what I have to do here, I have a radical left in the denominator, so I have to multiply by the radical that's left in the denominator. This will give me x square root y, and square root y times square root y is just y, times y is y squared. And that's going to be my final answer. The y and the y squared here do not cancel out because that is inside a square root and that is not inside a square root. Okay, 64, negative 3, square root 2 over 6, over square root 6, sorry. Make sure, good. Okay, so the 2 and the 6 are both inside a radical. They cancel out, or they reduce. So I have negative 3 over square root 3. Because here the square root 6, sorry, what was I thinking? Yes. So 6 and 2, they both reduce by 2. Up top, the square root of 1 is just 1, and 1 times 3 is negative 3. So that goes away. Let's multiply by the radical in the denominator. So that gives me negative 3 root 3. And the denominator, root 3 times root 3 is 3. And I have one more simplification I can do now. This just came out of nowhere, right? The 3 and the 3 cancel out. So there's my final answer, negative root 3. Okay, 65. Root 8 times root 10 is root 80. And I like to go ahead and multiply them together. You could work on the 8 here. 4 goes into it. But if you multiply it out, you can do all that looking for squares in one step. 16 is the biggest square root that goes into 80. And I'm going to show you something there in a minute. So I can say 4 times 5. Now, if you didn't see 16, if you just saw 4, let me show you an alternate reality here for 80. Okay, so let's say, let me scooch this over. Let's say you had 80, but you said, oh, 4 goes into it 20 times, so that's 2 root 20. Well, then you have to say, well, wait a minute, look at that 20. I know 4 goes into 20 as well. So let's break that up. Okay, the square root of 4 is 2, and 2 times 2 is 4. So we'll get to that same answer either way. If you find the big perfect square at first, though, it'll be a little faster. You can get right to your answer. If you find a smaller perfect square, that's okay, but you still have to look at the radical that's left to see if you can do anything else. Over here, I had root 5. 5 is a small prime number. Nothing will go into it, let alone a perfect square. Either way, though, same answer. Let's look at 66. Uh, 20, a squared b cubed. This is actually very similar to that worksheet I gave you, so hopefully this one wasn't that bad. This will be root 4 times root 5. 4 is the perfect square that goes into 20. So it'll be 2 root 5. How many times does 2 go into 2? 1 time. How many times does 2 go into 3? 1 time with 1 left over. So there is your final answer for that one. One more, 67. Again, 67 was also just like what we did last week. So root a3b5c3. Okay, no number out front, so nothing to worry about there. How many times does 2 go into 3? 2 goes into 3 once, with 1 left over. 2 goes into 5 twice, with 1 left over. 2 goes into 3 once, with 1 left over.